When Typhoon Emong reached the coast, the winds grew stronger and the sea turned violent.
Homes were flooded, boats were damaged, and community were forced to seek safety.
The destruction was clear and immediate, leaving many families struggling to recover.
But beyond that, there was another story quietly unfolding beyond the shorelines. Mangroves.
Mangroves are critical natural defenses against flooding and coastal erosion. However, successful mangrove rehabilitation depends on one overlooked resource: soil. Without proper soil quality, restoration efforts fail, wasting time, money, and materials. Today, soil sourcing in mangrove areas is manual, inconsistent, and difficult to scale, limiting both environmental impact and commercial potential.
After the typhoon, soil testing becomes essential to understand the condition of the land.
But working in disaster-hit areas is difficult, especially with muddy and unstable ground.
Laptops and manual tools require dry surfaces, electricity, and time, resources that are often unavailable.
This leads to our study, commercialization of Rhizophora Apiculata, and compatible soil using a semi-autonomous soil testing robot.
To address this gap, we developed MangroPro, a semi-autonomous soil analysis robot designed specifically for mangrove and coastal environments. MangroPro transforms soil analysis from a manual process into a standardized field-ready system. It is equipped with interchangeable attachments, including a claw and a soil scoop, enabling efficient soil collection, handling, and adaptation to varying field conditions while maintaining operational consistency.
MangroPro uses an NPK sensor to measure moisture, pH, temperature, and nutrients level directly on site. These parameters allow instant soil classification, enabling operators to decide immediately whether soil is viable for rehabilitation or commercial use. By automating data collection, MangroPro reduces human error and speeds up decision-making in the field.
MangroPro is not just a testing tool, it is a business platform. Once soil is classified as viable, it is collected, packaged, and prepared for transport. This soil is supplied to landscaping companies, land restoration projects, mangrove rehabilitation initiatives, and LGU-led environmental programs. All field data is digitized and integrated into AI-based analytics, enabling demand forecasting, inventory tracking, and optimized logistics across multiple sites. This allows MangroPro to standardize pricing, ensure quality control, and scale operations efficiently. By filtering soil quality at the source, the system minimizes waste, lower operational costs, and delivers a consistent market-ready product, turning soil into a reliable revenue stream rather than unmanaged raw material.
MangroPro aligns business growth with sustainability. It begins with SDG 8, decent work and economic growth, by creating technology-driven livelihood opportunities, enabling efficient soil supply chains, and supporting scalable green enterprises and coastal communities. It supports SDG 13, climate action, by strengthening natural flood defenses through mangrove rehabilitation. It advances SDG 14, life below water, by protecting coastal and marine ecosystems that sustain fisheries and local industries. It reinforces SDG 15, life on land, by ensuring responsible soil sourcing, restoring degraded areas, and preventing land degradation. Sustainability is not an add-on, it's a competitive advantage.
By turning soil into a data-driven, scalable resource, MangroPro enables smarter decisions, from field testing to final distribution. Through partnerships with LGU Alaminos, Enro Alaminos, academic institutions, and environmental agencies, MangroPro creates a sustainable, revenue-generating system that protects communities while supporting economic growth. We are not just selling soil, we are providing a service built on data, reliability, and long-term value for both people and the planet.
From Type to Tribe,
Mula dito sa MPIC,
i-MangroPro na yan!